Made Hurricane Melissa so exceptional, at least in Jamaica, is that it's the strongest storm to ever make landfall there, at least in living memory and any historical observations we have. Across the wider Atlantic, it's also one of the strongest we've ever seen. It occurred at a time of extremely warm ocean temperatures across the Caribbean Sea and the Western Atlantic. Um, and it also took a path through the Caribbean, which meant it brought high winds and heavy rainfall to Jamaica, eastern Cuba, and several other islands nearby. So it brought widespread devastation across the Caribbean. So our study considered a range of historical observations, so weather observations over time, and climate model simulations. So simulating our climate as it is now with human emissions of greenhouse gases, so current concentrations of carbon dioxide in the air, and then the same climate but without those the carbon dioxide having been emitted by humans. By comparing all of those things, we can assess essentially how intense an event like Hurricane Melissa would be with and without human emissions of greenhouse gases. And when we do that, we look at a range of different properties of Hurricane Melissa. So we look at the rainfall, which caused a lot of flooding. We look at the high winds that obviously cause a lot of structural damage. And we also look at the environmental conditions. So out in the ocean where Hurricane Melissa intensified, and we look at basically how each of those has changed in a world that's been warmed by humans. What we find is that the rainfall has become approximately, or I would say even at least 9 to 10% more intense as a result of climate change. We find the winds are about 5 meters per second faster as a result of climate change. And we find that the environmental conditions, which were favorable, you could say, to a storm like Melissa intensifying, have become about 6 times more likely. One of the most important elements of this study was that this is a historically understudied region. So hurricanes are a severe threat to islands in the Caribbean, but compared to the US, which faces a lot of similar events, there are far fewer attribution studies and actually other scientific studies on the effects of climate change. So we encountered some of the challenges associated with this in the course of our study. And it was just hugely important to collaborate with local experts on the study, both to improve our understanding and to hear from them about what they need going forwards in terms of greater resources for research and also greater collaboration across different regions. People often say you can't attribute a specific extreme weather event to climate change. That was true maybe 20 years or so ago. But the field of event attribution has kind of rapidly developed since then. And while we can't say whether an event was per se caused by climate change, that's really because that doesn't really make sense as a question. There are now groups of scientists all around the world using all sorts of different methods that can assess the influence of climate change on individual events like Hurricane Melissa. And across the overwhelming majority, not all, but the overwhelming majority, we are seeing a growing role of climate change in these events. With COP30 approaching, there is certainly a growing awareness that climate change is happening now and manifesting in different types of extreme weather events around the world. So that includes events like Hurricane Melissa, where lots of attribution studies have shown a measurable impact of climate change. But I think we need to continue to be clear on a few points. So first is that greenhouse gases are ultimately what matters in events like Hurricane Melissa in determining how impactful they are for the people in their path. And until we reduce those greenhouse gas emissions, we can't reduce the risk of events like Hurricane Melissa. I think we also need to be really crystal clear on the fact that these impacts are accumulating now every year that we wait to reduce those greenhouse gases. And these events all around the world in a really interconnected global economy affect all of us. So an event might happen in even another continent, but can have ripple effects that affect everyone around the world.